Hey everyone, so today we're going to be talking about derivatives of carboxylic acid. These are going to be basically any group that has that same acyl group, which is the R double bond O, like this is the acyl group. And anything that looks like this, that has something in this position where X is here, it's going to be a derivative of a carboxylic acid. So the first thing we'll talk about is the naming of carboxylic acid derivatives. And so we know with carboxylic acid, we replace the suffix with oic acid or carboxylic acid if it's a group on a ring or something like that. So we just treat it as a substituent group, but it's still the highest priority group there. If we have a halide, I think we talked a little bit about this a while ago, then we replace the suffix with OYL and then with the name of the halide. So if it, so we have halide name. So an example, if X equals chlorine, then it will be chloride, right? So this would be like acetyl chloride or something like that. The OYL, when we talked about this before, it's either YL or OYL, just depending on if it has a common name or not. So this is just circumstantial, whether it's OYL or YL. If it's this group right here, so we haven't talked about these, but these are called acid anhydrides. And we just replace the acid at the end with anhydride is how we name these. If we have a symmetric anhydride, meaning that R equals R prime, then you just name one R followed by anhydride. And if you have symmetric ones, if R does not equal R, then you list them in alphabetical order. So that's how we're going to name acid anhydrides. Then we have esters we can talk about. And so esters are going to be split into two sides, right? So this is called this overall is called an ester, but this is called the carboxylic acid side. And this is generally referred to as the alcohol side. And what you do is you're going to be replacing, the carboxylic acid ending with 8, right? So ic goes to 8 at the end. So if we had benzoic acid, it goes to benzoate if it becomes an ester. And you're going to do the alcohol side, the alkyl group, so the alcohol R group, I should say. Then the carboxylic acid alcohol. The carboxylic acid R group, and then 8 at the end. And so we'll talk about an example of what that can look like. If we have an amide, right, so this is going to be an amide. We break that down similarly. This is I'm just going to type or write carb for carboxylic acid side, and then this side here, it can be any different degree of amine or classification. This is the amino side, the amine side. And so if it's just an NH2 group, then we just replace the ic ending or carboxylic acid. This goes to an amide ending. So if we have benzoic acid, then it goes to benzoamide. Or if it's hexanoic acid, it goes to hexanamide. If it's a carboxylic acid, then it goes to just carboxamide, right? If it's NR HNR or NR2, meaning that it's a secondary or tertiary, or it's going to be a primary secondary amine, then what you have to do is you put an N, then the amino R group, followed by the name right there, right? So if we have something where we have hexane and then it's attached to just a regular hexanamide or something, then it'll go. And so let me just write out what I'm saying here. If we have something like 1, 2, 3, 4, and then it's N, H, and then 1, 2, 3, like that. This group is called N-propyl because that's that group right there. And then we go into the name of the carboxylic acid as 1, 2, 3, 4, 5. And so then it'll be pentanamide is how we would name that, right? So that's this chain right here. If we have a secondary amine there, then we would just put NN or another N and describe that group as well. Right, so that's how we name amides. Then we have these, which are called, I'm going to do this in different colors so it's easy to see, thioesters. Right, and so thioesters, they're going to be similarly named to everything else we talked about, replacing the ic ending, right? So if it has a systematic name with OA or carboxylate, it's replaced by thioate or carbothioate, right? So this is the same as esters, but with thioate or carbothioate. Right, so it's going to be the exact same as esters in that case. So if you have butane butanoate, right, which is going to be an ester, then it becomes butane thioate, right? Or cyclohexane carboxylate becomes cyclohexane carboxylate, for instance. Okay, and then this last one is important for biology. And these are called acyl phosphates. And acyl phosphates are named by naming the acyl group and just adding the phosphate, right? So this is like formyl or whatever we talked about last time, benzyl. So you say like benzyl phosphate, for example, right? Or benzoyl phosphate, right? So name the acyl group followed by phosphate, right? And so this would be the acyl group, and then this is the phosphate. Right, so those are the basic naming rules for a lot of the carboxylic acid derivatives. I know it's a lot to remember. And so we have kind of a simple breakdown for each of them, right? They're basically all replacing ic acid ending with something specific to whatever the carboxylic acid derivative is. All right, so let's look at a couple of examples here. So this first one, we see that here we have a halide. So this is going to be an acyl halide, right? And so then the way that we that we named the acyl halides is we named the acyl group, right? And so this is the acyl group here. And this is 1, 2, 3, 4, 5, 6. Right, so this is probably going to be isohexoyl, or 1, 2, 3, 4, 5, 6. So it can be 1, 2, 3, 4, 5, 5 methyl chloride. Okay, so that's how we would name that group. It would be 5 methyl chloride. Right, where this is the acyl group name. And this is the halogen. All right, so 5 methyl chloride is how we do it. We have to name the acyl group and the other one. In the next one, we have a hexane with a, so the hexane is basically the acyl group here, and then we have carbonyl next to an amine, which makes this an amide. So what we're going to do is we're going to name the carboxylic acid side of the amide, or the acyl group here. We're not going to name it like an acyl group, we're just going to name the group. And so this is going to be cyclohexane, because that is the group here. And then it's going to be carboamide, right? Because if this was a carboxylic acid, we would say cyclohexane carboxylic acid, because it's treated as a group on the ring. But here we have carboamide because of the amide functional group here. All right, the next one, we see that this functional group right here is an anhydride. And then both of the groups on the side, these are both going to be benzene rings. And so we know when we name an anhydride, we replace the ic acid ending with just anhydride, right? So instead of benzoic acid, this is just going to be benzene anhydride. I don't mean not replacing the ic acid, but just replacing the acid, right? So this becomes benzoic, and then we just add anhydride. Right, so this becomes benzoic anhydride. So that's how we name the anhydride structure here. In this last case, we have an ester functional group. Right, this is an ester. And we know we have to name the alcohol side of the ester first, and then we name the carboxylic acid side. So first we have to identify this. We see here's the C double bond O, right? So this is the carboxylic acid side. And then the other side, this would be considered the alcohol side. So first we're going to name the alcohol side. And so that's going to be cyclopentane or cyclopentyl. And then on the carboxylic acid side, we see it 1, 2, 3, 4, right? So we have isobutyl, right? It's going to be the group itself. And so this is going to be isobutane. Oops. Iso, instead of butane, it's going to be butanoate. Right, so isobutanoate is what that would be named. Okay, so that's some practice using the naming skills. And next we're going to end up talking about a lot of reactions and general mechanisms for carboxylic acid derivatives.